So yesterday we did the graph of 1 over x, right? And we found that the graph looked something like this, where this piece looked like this, and this piece looked like this, right? So this was f of x equals 1 over x. Because when x was negative, the function was negative. I'd like to consider g of x equals 1 over x squared. So when x is negative, if I'm plugging it into g, what's going to happen with g if x is negative? Really? I mean, if you plug in x, you got to square it, right? So if you square a negative number, you can get a positive number. So in reality, this graph is going to look like this. It's going to be a lot steeper, but the idea is still the same. As x gets closer to 0, when you square it, it's going to become even smaller. And then if you divide 1 by a really, really tiny number, you get a really, really big number. So that's why those shoot upward to positive infinity. And then as x gets either really, really large or really, really negative, this gets really large, and 1 divided by a really huge number shrinks down to 0. That's why it kind of levels off like this. All right. But once again, you can see that there's a vertical line that the graph doesn't touch. It approaches that vertical line, but it doesn't touch it. And so that's called a vertical asymptote. So let's formally write down what a vertical asymptote is. So, basically a vertical asymptote is a vertical line that the graph approaches but does not touch or does not cross. So, the line x equals a is a vertical asymptote of f of x if the limit as x approaches a from the left of f of x is either positive or negative infinity. Now notice, it'll only be one of those, but it could be either one. Or the limit as x approaches a from the right of f of x equals either positive or negative infinity. And it need only be one of those. Technically speaking, you can just have a vertical asymptote that the graph approaches from one side. In fact, there's a function coming up later on in this course that only approaches a vertical asymptote from one side. If you're curious, it's a logarithm. You guys dealt with logarithms before? Okay. So, I have a theorem that goes with this. It doesn't have a name, it's just a theorem. If f of x equals p of x over q of x is rational, so in other words, p and q are polynomials, in which p of x and q of x have no common factor, and a is a 0 of q of x. So let's understand the setup before I write the conclusion of this. So if you have a rational function, but the key is that the two polynomials don't have any common factors, okay? And if a is a 0 of q of x, so in other words, where division by 0 would occur, then x equals a is a vertical asymptote of f of x. So as long as there's no common factor between the numerator and the denominator, wherever the denominator is 0, you get a vertical asymptote. Sound good? So obviously knowing where your vertical asymptotes are going to help you tremendously, or the fact that you would know where your vertical asymptotes are would help you tremendously in being able to graph something like this. And you are going to be expected to be able to graph something like this. Now, and that's something that's not on the practice test, but it will be on the test because I had to alter. Do you remember that one problem we had on the last test where I said I had to alter it a little bit? I had to alter a couple of the ones on this test. One of them is one of the quadratics where you have to graph the parabola. You got to find a whole bunch of stuff, but you got to graph it. And one of them is you've got to graph a ration. So bless you. We're going to learn how to do that in this section. You're going to need it for the test. All right. So let's say that f of x is equal to x over x squared minus 9. What I'd like to know is I'd like to know where the vertical asymptotes are. How could I figure that out? And a was a 0 of the denominator, right? So figuring out where the denominator is 0 would be key in finding your vertical asymptotes. How can I figure out where that's equal to 0? Don't mumble with me. Yeah, and how would you do that? You could factor it, or you could technically set it equal to 0 and solve it with the square root method. Either way, you're going to end up with plus or minus 3, right? So, in general, factoring is going to be better, because if you can factor, that way you can double check to see if there are any common factors between the numerator and the denominator. So our vertical asymptotes, and I'm lazy, so I like to call it VA for vertical asymptotes. You'd have x equals 3, x equals negative 3. Now a word about plus or minus here. If those were just values of x, and that was it, I'd be okay with plus or minus. But these are equations of lines, and it would be extremely sloppy to write one equation for two different lines. Therefore, in this case, I would not be very happy with a plus or minus. You understand my logic behind that? because there are two separate lines, they need two separate equations. So, and I will be extremely picky about this piece right here. Okay? Don't just write 3 and -3 for vertical asymptotes. They're lines. 3 and -3 are numbers. They have to have equations. And so I will be extremely picky to look for x equals 3 and x equals -3 in this case. So, let's try a different one. Now, hopefully you notice that the denominator is the exact same this time around, right? So I can still factor this. This is x plus 3 . So what do you notice? They have a common factor. So when I go to find the vertical asymptote, unless the factor, if the factor in the denominator were of higher degree than the common factor in the numerator, you'd still get a vertical asymptote there. But if they're the same degree, or if the numerator has higher degree, then that doesn't cause a vertical asymptote because of the common factor. Okay? So in this case, our vertical asymptote would simply be x equals 3. And the common factor doesn't give you a vertical asymptote, it gives you a hole. So if I were to draw this graph, so if 3 is here, then this piece would look like this, and this piece would look like this, except at -3 it'd have a hole in it. Because 3 or -3 still isn't in the domain because it causes division by 0, but you get 0 over 0, which is an entirely different issue. So therefore, because there's no vertical asymptote there, because of the common factor, you get a hole in the graph. Does that at all make sense? Well, if that was ask me something. It's because, essentially speaking, this cancels out everywhere except that spot right there. There's still a restriction on the domain because you still can't divide by 0. But because that essentially cancels out everywhere, instead of basically exploding and going to positive infinity or negative infinity or whatever like a vertical asymptote, because that basically cancels out everywhere, you just get a hole instead. Anything else related to that? Yeah, you got to watch out for common factors, because if you've got a common factor, then it's not going to give you a vertical asymptote even if there's division by 0. And I think that shows up at some point on one of the tests, probably. Say what? Where there's a spot where there's division by 0, but there's not a vertical asymptote because of a common factor, yes. Okay.